Hello everyone. In this video, we are going to look into the concept of dimensions from the chapter Units and Dimensions. Now, what are dimensions? Let's try to understand that first. If I take a square, let's say I take a square of length L. What is the area of square? If this is L, this is L. Area of square is how much? Area of square is L square, right? Now, how many dimensions does this square has? We all know this is a two-dimensional structure, so it has, we say, two dimension. Now, similarly, let me take a cube of side A. I have a cube of side A, something of this kind A. Now, what would be volume of this cube? We can say volume is A cube. Now, how many dimensions does this cube has? It's a three-dimensional figure, so it is 3. So how can I define dimension? So dimension can be the powers to which fundamental quantities are raised in an expression. So now let's see how do we define it. I hope this is clear. So what are dimensions? Dimensions are the powers to which fundamental quantities are raised in the expression of that particular physical quantity. So how do we define it? We define dimensions to be dimensions of a physical quantity are the powers to which the fundamental quantities must be raised to represent it. Now, to write the dimensions of a physical quantity, we must know either its definition or how it is related to the fundamental quantities. Now, how do we, and they are generally put in square brackets. So that's all about representation. But what is a dimension? Dimension is the powers to which fundamental quantities are raised to in the expression of a physical quantity. Now, let's look at the dimensions of the 7 physical quantities. We have seen that the 7 physical quantities are length, mass, electric current, thermodynamical temperature or temperature, luminance intensity, amount of substance, and time. So we have missed out time here. So time whose unit is S, right? These are the 7 fundamental quantities. How do we represent? The length is represented, the dimensions of length is represented by a capital L, and dimensions of mass is represented by capital T, electric current by A within the or I, and temperature by K or theta. Similarly, other quantities also. So the important thing is when we represent a dimension, how do we represent it? We represent it in a square bracket. Now let's see this one as an example. If I want to write the dimensions of volume, what is volume? Volume is length into breadth into height. Length is what? L. So breadth is also length, height is also length. So what will be volume? L cube. So dimensions of this is 3. L is 3. Similarly, density. Density is what? Mass per volume. Density is mass is m, and L cube. So density is how much? M L power minus 3 T power 0. This is an example to understand how do we find dimensions of any quantity. Just as an example, let's find dimensions of momentum. Now, what is momentum? Momentum is P equal to, we know, mass into velocity. Mass is what? Kilogram. So dimensions of mass is capital M. Now, velocity is what? Meter per second. So it is length per time. So its dimensions of momentum would be m power 1, right? M power 1, L power 1, T power minus 1, right? Now let's look at what is the dimensional formula. The expression which shows how and which of the base quantities represents the dimensions of a physical quantity is called the dimensional formula. So in this case, we have just seen momentum. Whatever expression we got, that is the dimensional formula of that particular quantity, momentum. Now, dimensional equation. An equation obtained by equating a physical quantity with its dimensional formula is called dimensional equation of that physical quantity. So what is an equation? So I equate that physical quantity with that particular dimensional formula. That becomes a dimensional equation. So we can represent, depending on the usage, we can have dimensional formulae or dimensional equations. Now in dimensions, how do we, there are certain rules that are necessary while taking into consideration addition or subtraction of physical quantities. The rules are, two physical quantities can be added or subtracted only when they have same dimensions. Now let me take an example, then you'll see how weird does it sound. So if I ask you what is 5 meters but 2 kilograms, I mean what is 5 meters plus 2 kilograms? So it really looks weird because we cannot add them. 5 meters plus 2 kilograms, we cannot add them. However, 5 meters plus 2 meters, we can definitely say 7 meters. 5 meters minus 2 meters, again 3 meters. So what does it mean? It means two quantities or two physical quantities or more than two physical quantities can be added or subtracted only when their dimensions are same. Otherwise, they cannot be added or subtracted. Now, in case of multiplication and division, there is no such rule. You can multiply or divide any two physical quantities irrespective of their dimensions. Like, definitely, if I say 4 kg by 2 meter. So what does it mean? It means 4 by 2 kg per meter. So it will give me linear mass density 2 kg per meter. So multiplication or division can be done for any physical quantities irrespective of their dimensions. Now, what are the uses of dimensions? Dimensions can be used to check whether a physical equation is correct or not. So what do I mean by that? Now let's say I take an example. We have F equal to MA. I need to check whether F equal to MA is correct or not. Now let's say I know F, dimensions of F is what? Kg meter per mass is m power 1, L power 1, T power minus 2. Now I'll check whether these quantities also have the same dimensions. So on the LHS, what are the dimensions? M power 1, L power 1, T power minus 2. Now on the RHS, what are the dimensions? M mass is m, acceleration is L by T square. So this is also ml T power minus 2. So LHS is equal to RHS. That is F equal to MA is a correct relation. So it's dimensionally correct relation. Now the next thing is to derive relationship between different physical quantities. Now sometimes when we don't know the relationship between physical quantities, like I have, let's say, some quantity x which depends on I'll say force and length. So I'll write it as x equal to force power a and length power b. Then I'll find what are the dimensions of this, what are the dimensions of it, and then I'll get a relation between those two. So we can derive a relation between these two physical quantities. So uses of dimensions are to verify the correctness of a physical quantity or equation and to derive a relationship between physical quantities. So there are some places where we could derive the relationship between some physical quantities without even experimentation. In that way, dimensions helped us to check whether that experimental data was initially correct or not. Hope you could follow this. Thank you very much for watching this video. Thank you again.